Hey guys, this is Josh from Mizner Math again. Today we're going to be doing a quick video on partial fraction decomposition, integrating using that method. And this is going to be part one of two videos. So this one's just going to be the cover-up method and the basics of it, and the next video is going to be more complicated examples with nonlinear factors in the denominator. So basically, partial fraction decomposition is going to be the method of integration you're going to use anytime you have an integral that's going to look something like f of x over g of x. So that's the fraction right here, and basically you're going to decompose it into two different things, or it could be more than two different things. So basically what you're going to do here is, let's say we have f of x is 3x plus 11, and then let's say the denominator is x squared minus x minus 6. Okay, and the integral. So basically what you're going to do is you're going to break this up, you're going to factor this denominator. Oh yeah, that's one thing that's really key, is if the denominator can be factored, then you know you can definitely do this method. So right here we're gonna factor out this denominator. So we're gonna just basically get 3x plus 11 over x minus 3 times x plus 2. So I'm gonna bring this down here, and basically what we're gonna do now is we're gonna make this 3x plus 11 over x minus 3 times x plus 2, and we're going to make this equal to a over x minus 3 plus b over x plus 2, because those are the two factors on the denominator right there. And the reason you do single variables here is because these are both linear factors on the bottom, so it's just x minus 3, x plus 2, something. It could be like 7x plus 12, anything like that, linear, and just a single variable in the numerators of these things. So, and whenever you have these single variables, except for when you have, say, a square here or something like that, you're going to be using just what's called the cover-up method. And it's kind of a shortcut. I'll get to the shortcut in a little bit, but I'm going to show you a little bit how it works, just so you understand it and you don't get totally confused by it. So basically what you're going to do to start out is, say I want to find the a, because eventually you want to find the a and the b, and then you solve the integral. So to find the a, say I multiply both sides by x minus 3 to get the a alone. X minus 3, that one's going to cancel right there. Multiply this side by x minus 3. Yeah, cancel that. All right, so this is going to be 3x plus 11 over x plus 2 is equal to a plus b times x minus 3 over x plus 2. And that's just because I multiplied it right there. So basically what you're going to do now is you're going to set this x minus 3, this factor you just multiplied by, equal to 0. And to do that, you're going to make x equal 3. So if you plug in 3 for x, that whole term's just going to go to 0. So you're going to be left with a. And on this side, you plug in 3. You're going to have 3 times 3 is 9, plus 11 is 20. So 20 over 3 plus 2 is 5. 20 over 5 equals a. So a equals 4. So that's, you solve for a. So now once you solve for a, you just got to solve for b, and then you can go ahead with solving the integral. So now to find b, we're going to do the exact same thing, but we're going to multiply by x plus 2 on both sides. So I'll just reset it up over here. We got 3x plus 11, x minus 3, x plus 2 equals a over x minus 3 plus b over x plus 2. Pardon my handwriting. But basically just do the same exact thing, multiply by x plus 2, and this is going to cancel. So it's going to cancel, so you're going to be left with 3x plus 11 over x minus 3 equals b, because this is going to be multiplied by x plus 2, and then you're going to set it negative 2, so it's going to be 0. So just cancel that out. It's going to be b. So then plug in the negative 2 you would to make this equal to 0. This x plus 2 equals 0. So you plug in negative 2, you get 3 times negative 2 is negative 6 plus 11 is 5. And then negative 2 minus 3 is negative 5. So that's just going to be b equals 5 over negative 5, which is equal to negative 1. So now you have a equals 4 and b equals negative 1. So now you're going to plug it back in right here. So you're going to have the integral of 3x plus 11 over x minus 3 times x plus 2 is just going to be equal to the integral of 4 over x minus 3 minus, so it's going to be plus the negative, so it's going to be minus 1 over x plus 2. So now you've officially completed your partial fraction decomposition, and now you just need to solve these two individual integrals. So you're going to break this up into two integrals. So you're going to do integral of that minus the integral of this. And to solve that, that's just going to be 4 times 1 over x minus 3, which is going to be the ln of x minus 3. So 4 ln of x minus 3. And don't forget always to use the absolute value signs when you have a variable inside that. And this one's going to be minus 1 over x plus 2 is just the ln of x plus 2. So that's going to be 1 minus the ln of x plus 2. And those, again, are just the properties of integrating. You know, 1 over anything is going to be the ln of that, barring a chain rule. So u sub in u equals x plus 2. The du would be just 1. So you're basically doing the ln of x plus 2 is where you do to integrate that right there. So yeah, and then you have this. So you're just going to add the c to the end of this because it's an indefinite integral, and that's going to be your answer for this problem. All right, and so then basically I'll show you what I just did was the cover-up method, but it was kind of the longer way of doing it, just kind of explain so you know what actually is going on. But if I were to do this example again, let me just erase all this for you and do this example for you again, I could do it a lot quicker and a lot simpler looking with the cover-up method. As long as you know what you're doing with the cover-up method, it'll be a lot quicker for you. So we have this. So I'm going to do this problem again by the cover-up method. You're going to have this 3x plus 11. So what you're going to do here is, let me write out this a plus b again. X minus 3, x plus 2 equals a over x minus 3 plus b over x plus 2. So you're just going to cover these up again. So basically what you're going to do is, instead of doing all the multiplying I just did, say you're going to cover up this x minus 3, just put your finger over it so you can't see it. Do the same thing on this side, x minus 3. All you're going to do is just plug in a 3, because make this equal to 0 over here. So you plug in that 3, and you're going to get, again, 20 over 5, and that's your a. And then you're going to do the same thing over here. Cover up the x plus 2, cover up the x plus 2. Plug in negative 2, because that's what makes it equal to 0. And you're going to get the exact same answer, which is going to be negative 1. It's going to be negative 2. It's going to be negative 5 over 5. All right, so, and then you do the exact same thing I just did to solve the integral. So if you guys learned something from that, and if you guys are looking for more complicated examples where these aren't just linear factors, I'll be posting a second video shortly. So if you guys learned something from that, and please send me up with a like, subscription. Don't forget, you can comment any problems you have or any specific things you want me to work out for you in the comment section for me.